April 21, 1945. Dessau, Germany. A German tank commander pressed his eye to the periscope and froze. Something was wrong. The barrel on that American tank across the rubble, it was impossibly long. Longer than anything he had ever seen. Longer than a king tiger. Longer than anything the Americans were supposed to have. He had 3 seconds to make a decision. He fired first. The shell screamed across 600 yards of broken city and missed by inches close enough that the American crew felt the shockwave through their hull. Inside that American tank, a corporal named John Irwin didn't flinch. He didn't pray. He simply acquired the target, exhaled, and squeezed the trigger. What happened next would be argued about by historians for the next 80 years. But here is what nobody argues about. One tank walked away from that intersection. And it wasn't German. Don't forget to hit like, subscribe, and turn on notifications so you never miss our next videos. Join us as we explore more stories, historical events, and inspiring moments from the past. This community is built for people who believe that history is not just facts, it's fire. My name is Staff Sergeant Joseph Madra, and until 3 weeks ago, I was just another American tanker trying not to die in somebody else's country. But the Army had just handed me the keys to the only vehicle of its kind in the entire European theater. A machine so experimental, it didn't even have a proper designation yet. A gun so long it required external stabilizer springs just to keep the turret balanced. A weapon that American ordnance engineers had been told repeatedly by men with stars on their shoulders was unnecessary, excessive, a waste of steel and resources. Those generals were wrong. And it cost thousands of American boys their lives before anyone admitted it. This is the story of the T26E4 Super Pershing, the tank that should have existed 2 years earlier, the gun that could have changed everything, and the crew of ordinary men who took an extraordinary machine into the rubble of a dying city and answered a question that had haunted American armor since the beaches of Normandy. Could America finally build something that a German tanker would fear? In the summer of 1944, the answer was a brutal, humiliating no. To understand what happened at Dessau, you have to understand what American tank crews had been living through for the previous 10 months. Not the sanitized version you read in press releases. The real version. The mathematical version. The version measured in burning Shermans and sealed letters sent to mothers in Ohio and Georgia and Iowa. The M4 Sherman was a fine tank for 1942. It was reliable, fast enough, easy to produce, and relatively simple to maintain. American industry churned them out in staggering numbers, and that industrial capacity would ultimately prove decisive in the war's outcome. But numbers only matter if your tank can survive the first engagement. And by the summer of 1944, survival was becoming a matter of pure luck. The German Tiger. 2. The König Tiger, the King. Tiger had entered service in Normandy in July 1944. It weighed nearly 70 metric tons. Its frontal armor was 150 millimeters of hardened steel, sloped at 50 degrees, creating an effective protection level that made it essentially impervious to every standard Allied tank gun then in service. The 75mm gun on a standard Sherman could not penetrate a King Tiger's front at any range, not at 100 yards, not touching the barrel to the armor plate. The physics simply didn't work. The improved 76mm Sherman was supposed to fix this. Ordnance officials had promised commanders it would handle anything the Germans fielded. General Dwight Eisenhower was told this directly. He believed them. He shouldn't have. When 76mm Shermans finally reached Normandy in July 1944, crews discovered the truth the hard way. The 76mm firing standard ammunition could penetrate 109 millimeters of armor at 1,000 meters. The King Tiger's glacis plate required over 200 millimeters of penetration to defeat. The numbers didn't lie. American tank crews were being sent into battle with weapons that could not kill their opponent frontally at any practical combat range. Meanwhile, the King Tiger's 88mm gun could destroy any Allied tank from over 2,000 meters away. 2 kilometers. German crews were killing Americans before the Americans even knew they were in danger. The mathematics of this situation were not abstract. They were intimate and personal. They showed up as burning vehicles on the sides of French roads, as crew members with third-degree burns, as the specific silence that settles over a unit after it loses men who didn't have to die. By the Battle of the Bulge in December 1944, the situation had reached a point of quiet institutional crisis. American commanders knew their tanks were outmatched. Tank crews knew it better than anyone. The men who drove Shermans had developed a dark and specific fluency in German armor capabilities, not because they were students of military history, but because their survival depended on knowing exactly how far away a Tiger could kill them, what angle offered the thinnest protection, which way to run when one appeared on the skyline. This knowledge was not empowering. It was exhausting. Every engagement against German heavy armor required American tankers to work around a fundamental deficit in their equipment to compensate with tactics and numbers and artillery for a firepower gap that should never have existed. Morale is difficult to quantify in official records, but it lives in the letters men wrote home, in the careful language veterans used decades later. When they described watching their friends' tanks brew up on a hillside, they couldn't approach from the front. None of this had to happen. The solution existed. It had existed for years, and it had been deliberately blocked by a single powerful man who turned out to be catastrophically wrong about what American tankers needed. Lieutenant General Leslie McNair commanded Army Ground Forces from 1942 until his death in July 1944. McNair was an artillery officer by training, an intelligent and capable administrator, and completely fatally mistaken about one central question: what American tanks needed to survive against German armor. McNair believed in tank destroyer doctrine. Tanks, in his view, existed to support infantry and exploit breakthroughs. Specialized tank destroyers, faster, lighter vehicles mounting powerful guns, would handle enemy armor. Tanks didn't need to fight other tanks. Therefore, tanks didn't need heavy guns or heavy armor. Therefore, the Sherman was sufficient. Therefore, the T26 heavy tank program, which had been testing prototypes since 1942, was unnecessary. McNair wrote this in memos. He argued it in meetings. He used his institutional authority to slow development delay, production approval, and ensure that a vehicle that could have saved American lives arrived too late to save them. Engineers at American ordnance facilities had been working on the T26 series since the T20 prototype in 1942. They tested different guns' transmissions, suspension systems. They developed the 90mm M3 gun that would eventually arm the M26 Pershing. They knew what German tanks could do because they had access to captured German armor and ballistic data. They knew what American tanks needed. They were told repeatedly that those needs were excessive. McNair died on July 25, 1944, when American bombers accidentally struck his forward observation position during Operation Cobra in Normandy. He was the highest-ranking American officer killed in the European theater. His death was a tragedy by any measure. But it also removed the institutional obstacle that had been blocking American heavy tank development for 2 years. Within months, the T26E4 received approval for production. The timeline was set. The tank would reach Europe eventually. But eventually in war is a word that contains multitudes of dead men. The Zebra mission delivered 20 T26E4 tanks to Belgium in January 1945. 20 tanks, for an entire theater of operations. They went to the 3rd and 9th Armored Divisions. Crews encountered a vehicle that was genuinely impressive: 46 tons, 102 millimeters of frontal hull armor. The 90mm gun that Ordnance had promised would change the equation. On February 25th, near the Ruhr River, the first combat engagement occurred. 4 days later, a T26E4, nicknamed Fireball, was ambushed and knocked out by a concealed Tiger, one firing from 100 yards through the machine gun port in the mantelet. The Pershing was better than the Sherman. It was not invulnerable. And against a King Tiger, the standard 90mm M3 gun still left American crews at a disadvantage at extended ranges. The mathematical problem had been narrowed. It had not been solved. The real solution, was already under construction in a facility in Ohio. In January 1945, engineers at Wellman Engineering Company began modifying a single T26E1 prototype. They removed the standard 90mm M3 gun and replaced it with something that had no precedent in American tank armament. The T-15E1 gun, a 90mm weapon with a barrel 73 calibers long compared to 53 calibers for the standard gun and a chamber capacity that generated muzzle velocities approaching 1,140 meters per second. For reference, the standard M3 gun managed 810 meters per second. The T-15E1 fired its tungsten-cored armor-piercing round 40% faster. The penetration numbers were staggering. At 1,000 meters, the T-15E1 firing T-30E16 APCR ammunition could punch through 260 millimeters of armor. The King Tiger's frontal glasses required approximately 200 millimeters to defeat. For the first time, American ordnance had built a tank gun that could look a King Tiger in the face and kill it before the German crew could return the favor. The gun was so long 21 feet of barrel that it required external stabilizer springs mounted on the turret sides just to maintain balance. The ammunition was 50 inches in length, making stowage inside the tank a logistical nightmare. Loading the weapon required a specific sequence practiced until it became automatic. The whole system was by any reasonable engineering standard extreme, borderline impractical. The kind of solution that only makes sense when the alternative is watching your crews die in tanks that can't fight back. One vehicle was completed. 1. The T26E4 Super Pershing shipped to Europe in mid-March 1945 and was received by the Maintenance Battalion of the 3rd Armored Division. Captain Belton Cooper, the division's maintenance officer, stood in the yard as the tank was unloaded and stared at the gun barrel extending far beyond the front of the vehicle. He understood immediately what he was looking at. He also understood what the tank lacked. Despite the extraordinary gun, the T26E4's basic armor was identical to the standard Pershing, adequate against Panthers, insufficient against a King Tiger's 88 millimeters at range. Cooper's maintenance crews improvised a solution that would have seemed insane anywhere except a combat zone. They found destroyed Panthers in the wreckage of the division's advance through Germany and cut armor plate from the hulls. Two 38mm steel plates went on the hull front, creating a triple-layer package totaling 178mm at the glacis. An 80mm plate from a Panther's upper glacis was welded directly to the gun mantlet with 3 holes cut for the gunner's sight, the main gun, and the coaxial machine gun. Additional Panther plates went on the turret sides as counterweights to handle the extra mass on the mantlet. This field modification added approximately 5 tons to a vehicle already at the edge of its powertrain's capacity. The Ford GF engine, rated at 500 horsepower, had been designed for 46 tons. It was now pushing 51. Performance suffered, but the crew now sat behind armor that could absorb hits that would have killed them in a standard Pershing. The resulting vehicle looked like nothing else in the American inventory. The plates were welded at rough angles, the stabilizer springs stood out from the turret like mechanical wings, and the gun barrel extended so far forward that making tight turns in urban environments required careful calculation to avoid embedding 21 feet of steel in a building wall. It was ugly. It was improvised. It was a jury-rigged answer to a problem that proper planning could have solved years earlier. Staff Sergeant Joseph Madra took command in April 1945. His gunner, Corporal John Irwin, was an experienced tanker who had fought through the European campaign and understood with the intimate knowledge of a man who had survived exactly what the capability gap between American and German armor meant in practice. Now he sat behind a gun that changed that calculation entirely. The Super Pershing saw its first combat on April 4th between the Weser River and Northeim. The 3rd Armored Division's Spearhead encountered a German position on a wooded hill that opened fire on the column. The Super Pershing traversed its turret. Irwin acquired a target at approximately 1,500 yards, a range at which standard American tank fire was often ineffective against heavier German armor. He fired a single armor-piercing round. Witnesses described a tremendous explosion. Debris shot 50 feet into the air. The target was destroyed instantly, The engagement lasted seconds, 1,500 yards, one shot, one kill. The gun worked. The word spread through the regiment with the speed that important information always moves in combat units, faster than official channels, more reliably than reports. Something had changed. The Americans had a weapon that reached out to 1,500 yards and ended vehicles that previously had to be maneuvered around flanked called-in artillery on prayed away. The destroyed vehicle was likely a Panther or lighter armored unit based on the explosion characteristics. The Super Pershing had not yet faced a King Tiger. That question remained open. Then came orders to advance toward Dessau. Dessau in April 1945 was a nightmare of broken concrete and exposed steel, of streets choked with rubble from weeks of Allied bombing, of burned vehicles and collapsed facades that turned every intersection into a potential ambush. The Junkers aircraft factory had made the city a priority target for Allied bombers, and what remained was a skeleton of a city still populated by German troops with nowhere left to retreat. The 33rd Armored Regiment entered Dessau on April 21st. The Super Pershing moved through the city as part of the spearhead Madra in the commander's cupola, scanning the rubble, while Irwin tracked potential targets through his sight, that extraordinary gun traversing slowly across shattered buildings and blocked streets. At an intersection somewhere in the broken heart of Dessau, the Super Pershing turned a corner. And 600 yards away, a German tank crew saw the barrel. That gun, that impossible barrel. Longer than anything in the German inventory. Longer than their own King Tiger. The German commander had 3 seconds. He fired first. The shell passed so close to the Super Pershing that the crew felt it. Missed. In the chaos of urban combat with rubble obscuring precise range estimation, the German gunner had the range, but not the angle. A near miss that was close enough to taste. Inside the Super Pershing, Irwin was already traversing, already acquiring, already breathing out. He fired a high-explosive round first. It struck the German tank and failed to penetrate, confirmation that whatever he was facing had real armor, real protection. The German tank began to move, rolling forward, attempting to use a pile of rubble as cover or as an escape route. As the German vehicle crested the debris pile, something happened that the crew could not have anticipated. The belly of the tank, the thinnest armor on any armored vehicle, the area no commander expects to expose in combat, rotated upward and into Irwin's sight picture. He fired. The armor-piercing round struck the underside of the German tank. The belly armor, thin by design because tank designers never intended it to face direct fire, offered no meaningful resistance. The round penetrated. It detonated the ammunition stored inside the hull. The turret came off the vehicle and landed in the street. The engagement lasted approximately 20 seconds from first shot to final explosion. But here is where history becomes complicated. Here is where the mythology and the mathematics begin to separate. The crew identified the destroyed tank as a Tiger. Later analysis of German unit records would place the nearest King Tiger units approximately 70 miles from Dessau on that date, engaged around Berlin against Soviet forces. No German records document King Tiger operations in the Dessau area. American after-action reports from Dessau specifically noted Panthers and Panzer IVs, but made no mention of Tiger IIs. The destroyed tank was almost certainly a Panzer IV, a capable vehicle, a real threat, but not a King Tiger. The mythology that grew around this engagement transformed it into the confrontation American tankers had been waiting for since Normandy. The American supertank finally killing the German supertank, technological parity achieved in a 20-second duel in a ruined city. The truth was more complicated, more ambiguous, and in some ways more important. Because the real story wasn't whether John Irwin killed a King Tiger or a Panzer IV in the streets of Dessau. The real story was what it meant that America had finally built something a German tanker might genuinely fear. That a single crew in a single experimental vehicle had demonstrated that the capability gap, the gap that had been killing American boys since Normandy, could be closed. The question was what happened next, because the war was almost over. Because there was only one Super Pershing in Europe, because 300 standard M26 Pershings had reached the theater, but fewer than 20 had seen combat. Because thousands of Sherman crews were still fighting through Germany with 75mm and 76mm guns that couldn't reliably defeat what they faced. The mathematics of what might have been sat alongside the mathematics of what actually happened. And in Part 2, we'll see what the Germans who survived these final weeks of the war said when Allied intelligence sat them down and asked them directly, "What did you think of American armor? What did you think of the Pershing? And what would you have thought, what would have changed if 500 Super Pershings had rolled off American production lines in 1943, instead of one experimental prototype arriving in March 1945? The answer is more devastating than the shell that blew a turret into a Dessau street. Stay with us. In the rubble of Dessau, a turret flew off a German tank and landed in the street. One shot. 20 seconds. One crew in one experimental vehicle proved that America could finally build something a German tanker would fear. Staff Sergeant Joseph Madra and Corporal John Irwin had taken the T26E4 Super Pershing, the only one of its kind in the entire European theater, and demonstrated what 73 calibers of gun barrel could do when a man who knew how to use it sat behind the sight. But here is what the mythology never tells you. Here is the number that changes everything. By April 21, 1945, the day of the Dessau engagement, the war had approximately 17 days left. 17 days. And there was still exactly one Super Pershing in Europe. The question was never whether the gun worked. The question was why it took until the final weeks of a dying war to put it there. And the answer to that question leads directly to a conference room in Washington, where a general with a chest full of medals told an engineer that his ideas were wasteful, excessive, and unnecessary, while American boys burned inside Shermans that couldn't fight back. That general's name was McNair, and he was not alone. Lieutenant General Leslie McNair commanded Army ground forces and embodied a doctrine that shaped American armor throughout the entire European campaign. But McNair had subordinates who shared his convictions and outlasted him. When McNair died in July 1944, the institutional machine he had built continued running. Officers who had built careers around tank destroyer doctrine did not simply reverse course because the man at the top was gone. Bureaucracies do not work that way. They protect themselves. The engineers at American ordnance facilities who had been developing the T26 series since 1942 understood this intimately. They had watched prototypes gather dust. They had written reports demonstrating penetration values, armor protection calculations, ballistic data from captured German tanks, and watched those reports disappear into committees that had already decided the answer. One of those engineers was a man who understood not just metallurgy and ballistics, but the specific frustration of being technically correct while institutionally powerless. When the T-15E1 gun project began in January 1945, the men working on it knew they had perhaps 8 weeks before the European War reached a conclusion that would make their work irrelevant. They worked anyway, because the alternative was watching the problem continue. The first formal review of the T26E4 program came in February 1945, before the tank shipped to Europe. The meeting included ordnance officials, armor branch representatives, and a brigadier general whose primary concern was production standardization. His position was straightforward and, in its own terms, not unreasonable. "You're asking us to tool up for an ammunition type we can't produce at scale," he said, looking at the specifications for the T30E16 APCR round. 50-inch ammunition, tungsten cores, limited tungsten availability, one prototype. What exactly are we approving here? The engineer presenting the data kept his voice level. "We're approving a weapon that can kill a king tiger frontally at 1,000 meters. The standard M3 cannot do that at any range. The standard M3 is in production. The standard M3 is in the hands of crews who know how to use it. The war in Europe is nearly concluded. It was nearly concluded in September. Men are still dying in Shermans." The room was quiet for a moment. "Ship the prototype," the general said finally. "One vehicle. Combat evaluation. We'll assess the data when it comes back. One vehicle. A combat evaluation that would last 17 days before German surrender ended the war. The institutional machine had processed the request to prove the minimum possible commitment and protected itself from any accusation of blocking progress while ensuring that progress remained contained. This is how bureaucracies survive being wrong. They approve just enough to avoid blame and not enough to change anything. The engineer who had presented the data walked out of that meeting and found Captain Belton Cooper waiting in the corridor. Cooper was the 3rd Armored Division's maintenance officer, the man who would receive the Super Pershing when it arrived in Europe, the man who would weld Panther armor onto its hull with salvaged steel and improvised solutions, because the vehicle as designed still wasn't protected adequately against what it would face. Cooper had heard enough through the door to understand the decision. "One vehicle," he said. "One vehicle." Cooper was quiet for a moment. Then, "Tell me about the armor situation on the hull." This was the unexpected alliance that mattered. Not a dramatic moment of a senior officer risking his career to champion a revolutionary weapon. Something smaller and more real. A maintenance officer who understood field engineering, who would receive this experimental machine in a combat zone and immediately recognize both its capability and its vulnerability, and who would improvise a solution from destroyed enemy equipment rather than wait for official modifications that would never arrive in time. Cooper's contribution to the Super Pershing's combat effectiveness was as significant as the gun itself. Without the field modifications, the Panther armor welded to the hull front. The 80mm plate covering the mantlet, the T26E4, was an extraordinarily powerful gun mounted in a vehicle that a King Tiger could kill at 1,500 meters before the American crew could close to effective range. With the modifications, the Super Pershing became something approaching a genuine heavy tank. Not perfect, not equal to a King Tiger in pure armor terms, but viable, survivable, capable of taking a hit and returning fire. The logistics of the modification were genuinely remarkable. Cooper's crews identified destroyed Panthers during the division's advance through Germany and cut usable armor plate from the hulls. 2 38mm plates went to the hull front. An 80mm section from a Panther glacis went to the gun mantlet. The total added weight was approximately 5 tons, bringing the vehicle to over 50 tons on a powertrain rated for 46. The Ford GF engine produced 500 horsepower and was now being asked to move a vehicle 10% heavier than its design specification. Performance dropped. The tank was slower, less responsive on inclines, harder on the transmission. Nobody complained, because the alternative was going into combat in a vehicle where the crew knew with mathematical certainty that specific German guns could kill them frontally, at distances they couldn't close before being destroyed. This is the detail that post-war mythology consistently underplays. The men who fought in these tanks were not abstract statistics. They were people who had done the arithmetic of their own survival. They knew what guns German tanks carried. They knew penetration values at combat ranges. They knew which angles offered protection and which didn't. When Cooper's maintenance crews welded Panther steel onto the Super Pershing's hull, every man watching understood exactly what problem was being solved and why it mattered. The Super Pershing's first combat on April 4th validated the gun's performance in a way that no test range could replicate. The target at 1,500 yards, likely a Panther or self-propelled gun based on the explosion signature, was destroyed with a single shot. Witnesses described debris climbing 50 feet into the air. At 1,500 yards, standard American tank fire against heavier German armor was often ineffective. The Super Pershing made it look routine. Word moved through the regiment. Crews asked questions. Officers who had spent years working around the capability gap between American and German armor heard a number 500 yards one shot and recalculated their assumptions. Then came Dessau and the engagement that would become legend. The 22nd encounter at the intersection. The near miss from a German tank that fired first. Irwin's first round striking and failing to penetrate, confirming real armor. The German tank cresting the rubble pile, exposing its belly. The second shot. The turret in the street. Whether the destroyed tank was a Panzer IV, a Tiger I, or a King Tiger remains historically contested. German unit records place the nearest Tiger, 2 formations, 70 miles away, engaged around Berlin. American after-action reports from Dessau list Panthers and Panzer IVs, but no Tiger IIs. The most probable explanation is a Panzer IV misidentified in the chaos and limited visibility of urban combat, common enough that experienced crews frequently reported vehicles as Tigers when engagement stress and restricted sight lines made identification genuinely difficult. This does not diminish what happened. It clarifies it. The mythology says America's supertank killed Germany's supertank in a climactic duel. The history says an experienced American gunner used an exceptional weapon to destroy a German armored vehicle in 20 seconds under combat conditions in a rubble-choked city, displaying the kind of gunnery and situational awareness that can only come from training experience and the specific calm that settles over men who have decided they will do their job, regardless of what happens. Both things can be true. The mythology serves its purposes. The history serves different ones. On April 22nd, the day after the famous engagement, the Super Pershing encountered a disabled Panther whose hull was immobilized but whose turret remained operational. The Panther crew fired. The Super Pershing fired back. The Panther was destroyed, what Irwin described as a clean kill. Later that same day, 2 German medium tanks identified as Panzer IVs crossed the Super Pershing's field of fire. Irwin destroyed the first. The second stopped. The crew got out and surrendered. They looked at that gun barrel, 21 feet of steel extending from the turret. They made a decision. This was the Super Pershing's complete combat record, a handful of engagements across 3 weeks. 1 experimental vehicle. And then, on May 8th, Germany surrendered, and the question of what 500 such vehicles might have accomplished became permanently theoretical. The post-war evaluations confirmed what the engineers had calculated and what Irwin had proven in practice. The T26E4 gun's penetration values exceeded the King Tiger's 88mm KWK-43 when both fired their best available ammunition. At 1,000 meters, 260 millimeters of penetration against a vehicle requiring approximately 200 millimeters to defeat frontally. The Super Pershing could kill a King Tiger at ranges where the German gun could kill back genuine parity for the first time in a single American tank. The standard M26 Pershing did not achieve this. The 90mm M3 gun penetrated approximately 115 millimeters at 2,000 meters against armor angled at 30 degrees. The King Tiger's gun penetrated 132 millimeters at the same range. The gap was narrower than the Sherman versus Tiger gap, but it was still a gap, and gaps in armor-piercing capability are measured in crew deaths. What the post-war record revealed most clearly was the cost of the institutional delays. The T26 program had been in development since 1942. 3 years. The engineering was not the problem. The ballistics were understood. The armor requirements were calculable from captured German vehicles. The obstacle was doctrine, specifically the belief held by McNair and the apparatus around him that American tanks existed to support infantry and exploit breakthroughs rather than to fight other tanks. A doctrine that ignored the reality that enemy tanks consistently appeared wherever American armor advanced. German prisoners interrogated by Allied intelligence after the war expressed consistent respect for American combined arms tactics, artillery integration, and logistical capability. They acknowledged the Pershing as a genuine improvement over the Sherman. They confirmed that the King Tiger retained firepower advantages over the standard Pershing at extended ranges. None of them expressed surprise that it had taken America until 1945 to build a heavy tank. They had their own institutional failures, their own programs canceled or delayed or mismanaged. The Tiger II itself, for all its formidable specifications, arrived in insufficient numbers and with chronic mechanical problems that limited its operational effectiveness far below what its technical specifications suggested. A King Tiger with fuel and ammunition and a trained crew was a fearsome weapon. A King Tiger stranded for lack of fuel was 70 tons of expensive scrap. The Super Pershing story is not primarily a story about a tank. It is a story about institutions and the specific human cost of institutional failure. About engineers who were right and were ignored. about crews who knew the mathematics of their own vulnerability and compensated with tactics and courage and numerical superiority. About the distance between what industrial capacity could produce and what doctrinal rigidity allowed. In Part 3, we will follow what happened when Allied intelligence teams entered occupied Germany and began the systematic evaluation of captured German armor. They found King Tigers in varying states of condition. They measured. They tested. They confirmed the numbers that American ordnance had calculated and the numbers that McNair had dismissed. And they wrote reports that would reshape American tank doctrine for the entire Cold War. Because what those engineers found in the wreckage of the Third Reich was not just data about German tanks. It was the blueprint for what American armor would need to become if the next war required fighting an opponent with heavy armor long-range guns and the institutional willingness to use them. The Cold War was 3 years away. The Soviets were already building the IS-3, and the question of whether America had learned the right lessons from the Super Pershing was about to become the most important question in armored warfare. The answer, as you'll see, was more complicated than anyone wanted to admit. The Super Pershing destroyed a German tank in Dessau in 20 seconds. One crew, one experimental weapon, and a gun that finally gave American armor something it had lacked since Normandy, the ability to fight back on equal terms. Then, Germany surrendered. And the real reckoning began. Because when Allied intelligence teams entered occupied Germany in May 1945 and started measuring what they found, cutting apart King Tiger hulls firing, captured 88mm guns at captured Allied tanks running the numbers that field commanders had estimated for years, what they discovered was more disturbing than anything that had happened in combat. The gap had been larger than anyone officially admitted, and the Soviets had already seen the data. 3 years after the war ended, they were building something in response. And what they built would force the United States to answer a question that the Super Pershing had only partially answered. Had America actually learned anything? In the spring and summer of 1945, as Allied forces processed the wreckage of the Third Reich, German tank crews who had survived the war found themselves in interrogation rooms across occupied Europe. American and British intelligence officers asked systematic questions about German armor capabilities, tactical doctrine, and assessments of Allied equipment. The answers were recorded, compiled, and forwarded up chains of command that were already pivoting from the question of defeating Germany to the question of what came next. The German tankers were professional. They answered questions with the specificity of men who had spent years thinking about nothing but the mathematics of armored combat. They described the King Tiger's 88mm KWK-43 with clinical precision. They confirmed penetration values at extended ranges. They acknowledged the Pershing as a genuine improvement over the Sherman, while noting that the standard 90mm M3 gun did not achieve parity with their heaviest weapon at distances beyond 1,500 meters. One interrogation report compiled from multiple German tank commanders captured the institutional assessment with characteristic directness. The Americans had arrived at the right answer too late and in insufficient numbers to affect the outcome. The standard Pershing narrowed the gap. The Super Pershing closed it. Neither appeared in quantities that forced German tactical doctrine to change. This was the critique that cut deepest. Not that American technology was inferior, the Super Pershing proved it wasn't, but that American institutional processes had delivered the right technology after the problem it was designed to solve had been resolved by other means. By numerical superiority, by air power, by logistics, by the accumulated weight of industrial capacity applied at a scale Germany could not match. The post-war testing confirmed the arithmetic. King Tiger frontal armor, 150 millimeters at 50 degrees on the glacis, 180 millimeters on the turret face. Standard M26. Pershing 90mm M3 gun penetration at 1,000 meters, approximately 122 millimeters. Insufficient to defeat the glacis at any practical combat range. The Super Pershing T26E4 gun at 1,000 meters, 260 millimeters. More than sufficient. Definitively superior when firing the best available tungsten cord ammunition. The numbers were entered into reports that circulated through the Army Ordnance community, through Armor Branch, through the offices of men who were already thinking about a different adversary. The Soviets were not unaware of any of this. Soviet intelligence had monitored American tank development throughout the war. The Lend-Lease program had given Soviet engineers access to American tanks, including Shermans, and they had conducted their own comparative evaluations against German armor. Soviet engineers understood the capability gaps between American German and Soviet designs with the same mathematical clarity that American engineers applied to captured German vehicles. The IS-3 heavy tank entered Soviet service in 1945, arriving too late for the European War, but appearing in the victory parade through Berlin in September of that year. Western military observers who watched those IS-3s roll through Berlin did so with expressions that Allied newsreel footage captured but could not fully convey. The IS-3 weighed 46 tons. Its frontal armor consisted of a dramatically angled pike nose configuration. 110 millimeters of steel sloped at 56 degrees, creating effective protection values that exceeded every tank gun then in American service. The pike nose design was not accidental. Soviet engineers had studied captured German tanks, including Tiger IIs, and had studied the ballistic properties of sloped armor with the same rigor that German engineers had applied to the same problem. The result was a vehicle that applied the lessons of World War II German heavy tank design more effectively than the Germans themselves had managed in the Tiger II. The IS-3 could not be reliably penetrated frontally by the standard M26 Pershing's 90mm M3 gun at any practical combat range. The gap that had existed between American and German armor in 1944 had reappeared with a different adversary wearing different insignia. This was the crisis that the Super Pershing's brief combat career had not resolved. It had demonstrated that American industry could produce a gun capable of defeating heavy armor when forced to do so. It had not demonstrated that American institutional processes could deliver such weapons before the tactical problem they addressed had already claimed an unacceptable number of lives. The M26 Patton addressed part of the problem. The original M26 Pershing's Ford GF engine had been adequate for 46 tons, with limited margin. Crews who had driven Pershings complained about sluggish acceleration, limited top speed on inclines, and a transmission that required careful management to avoid damage. The M46 replaced the powertrain with the Continental AV1790, developing 810 horsepower against the original engine's 500. The performance improvement was immediate and substantial. Acceleration improved. Hill climbing capability increased. The transmission proved more reliable under sustained combat conditions. The M46 entered service in 1948. When North Korean forces crossed the 38th parallel in June 1950, driving Soviet-supplied T-34/85 tanks, the M46 met them. The T-34/85 was not a Tiger II. It was a medium tank that had proven devastating against early-model Shermans in the hands of North Korean crews, who advanced faster than American forces could respond in the opening weeks of the war. M24. Chaffee light tanks, which constituted most of the American armor initially available, were completely outmatched. The T-34/85's 85mm gun penetrated Chaffee armor easily. The Chaffee's gun could not reliably defeat T-34 frontal armor at combat ranges. This was July 1950. American tankers were dying in vehicles that couldn't fight back. It was 1944 in France again, with different tanks and different terrain and the same brutal arithmetic. The M46 changed that arithmetic. At the Battle of Taibjon on July 20, 1950, American infantry, equipped with 3.5-inch rocket launchers and supported by M4 Sherman tanks, suffered significant casualties against advancing T-34/85s. The 3.5-inch rocket launcher rushed into service as an emergency measure could penetrate T-34 armor, but required crews to approach within 100 meters, a death sentence against a tank with functioning machine guns. The M46's arrival in theater in August 1950 shifted the engagement parameters. The 90mm M3A1 gun mounted on the M46 could penetrate a T-34/85 frontally at ranges exceeding 800 meters. The T-34-85's 85mm gun could not reliably penetrate M46 frontal armor at combat ranges. For the first time in the Korean War, American tankers faced an opponent they could kill before being killed. The engagement records tell the story with the clarity that combat data always provides. American M46s destroyed T-34/85s at ranges between 400 and 1,200 meters across multiple engagements in the fall of 1950. T-34/85 crews, trained on tactics developed against the less capable Sherman, found that the approach distances and engagement angles that had worked in July were now suicidal. They adapted. They became more cautious. They sought terrain that neutralized the M46's range advantage. The tactical initiative which North Korean armor had held through July and August shifted. This was the payoff the engineers had promised and the institution had delayed. Not in Germany in 1944. Not in the streets of Dessau in April 1945. But in Korea in 1950, where a design lineage that ran directly from the T26E3 through the M26 Pershing to the M46 finally met an opponent it was specifically capable of defeating at the ranges where the engagement would be decided. The numbers from Korea were specific. American M46 engaged and destroyed North Korean T-34/85s with a kill ratio that American armor had not achieved against German heavy tanks in World War II. Across the period from August to November 1950, American tank units reported M46 versus T-34/85 engagements, with favorable outcomes in the large majority of documented cases where American crews achieved the first shot at combat ranges. The T-34/85's gun proved unable to penetrate M46 frontal armor, reliably creating exactly the asymmetric situation that German Tiger crews had exploited against Shermans in Normandy, but now running in the opposite direction. The tactical consequences extended beyond tank versus tank combat. North Korean commanders, recognizing that their armor could no longer operate against American positions with the confidence that had characterized early operations, began holding T-34/85 formations back from direct engagement. Tanks that had led advances in July were used in support roles positioned to provide fire against infantry rather than seeking direct engagement with American armor. This tactical shift reduced the offensive effectiveness of North Korean armored forces substantially. By November 1950, Chinese intervention introduced new tactical complications that went beyond armor versus armor combat. But within the specific context of the T-34/85 versus M46 matchup, the record was clear. American armor had achieved technical superiority over the opponent it faced. The capability gap that had defined American armored combat in World War II had been closed not against the opponent that forced its creation, but against the next opponent who appeared before American institutional processes found a different reason to delay. The broader lesson sat in the gap between these two histories. In World War II, American industrial capacity had been capable of producing the T26/M26 Pershing from 1943 onward. The engineering was complete. The ballistic data was available. The manufacturing capability existed. The delay was institutional doctrinal disagreements, bureaucratic resistance, a senior officer's conviction that the need didn't exist, even as the evidence of need accumulated in casualty reports from France and Belgium and Germany. In Korea, the M46 arrived early enough to change the outcome of the tank versus tank fight. Not because American institutional processes had fundamentally changed, but because the M46 was a modification of an existing design that required less development time, because the Korean War began with American forces already aware of the T-34/85's capabilities from intelligence assessments, and because the post-war reform of American armor doctrine, driven partly by the painful lessons of World War II, had produced a slightly faster response to demonstrated need. Slightly faster. The Chaffees that burned in July 1950 represent the margin of time between slightly faster and actually fast enough. What happened to the men who had built and fought with the Super Pershing Joseph Madra and John Irwin survived the war? They returned to civilian life as millions of veterans did, carrying the specific knowledge of men who had sat inside experimental vehicles in dying cities and discovered through direct experience what American industry could build when it had to. Irwin wrote about the Dessau engagement years later. His account is the primary source for the details of the 22nd encounter at the intersection, the near miss. The first shot, the German tank cresting the rubble pile, the shot to the belly, the turret in the street. He was precise about what he saw and appropriately uncertain about what he couldn't confirm. He did not claim to have killed a king tiger. He described what happened and let the record stand as it was. Captain Belton Cooper, the maintenance officer who had welded Panther armor onto the Super Pershing's hull, wrote a memoir decades later, Death Traps, that documented the maintenance battalion's experience throughout the 3rd Armored Division's campaign in Europe. Cooper was specific about the institutional failures that had cost lives, about the gap between what American industry could have produced and what American doctrine allowed it to produce. His account is not abstract. It is built from the specific memory of receiving damaged tanks, assessing casualties, and understanding with the knowledge of a maintenance officer exactly what design failures had contributed to which deaths. The engineers who had developed the T26E4 gun, the weapon that actually achieved parity with the King. Tiger watched the post-war evaluations, confirmed their calculations, and the Cold War created demand for exactly the capabilities they had built. The T26E2, which addressed the stowage problems of the original T26E1 through a 2-piece separated ammunition design, was developed and tested. It fed into the design process for the guns that would arm the M47 and M48 Patton series. The M60, which entered service in 1960 and remained in frontline American service through Operation Desert Storm. In 1991, mounted a 105mm M68 gun capable of defeating Soviet heavy tank armor at combat ranges. The design philosophy, overwhelming firepower, combined with adequate protection and reliable mobility, traced directly back to the lessons that the Super Pershing program had embodied and that McNair's doctrine had delayed. 30 years of American armor design philosophy ran through a single experimental vehicle that fought for 3 weeks in a dying war and fired its gun in anger fewer than 10 times. But here is the question that Part 4 will answer. The question that the official records don't fully address, that the post-war evaluations document, but don't resolve, that the men who built and fought with the Super Pershing carried with them into civilian life and never entirely put down. If the institutional failures of the American tank development program had been corrected in 1942 rather than 1945, if McNair's doctrine had been tested against battlefield reality in Tunisia rather than accepted as axiomatic, how many men who died in burning Shermans would have lived? The number is not in any official report. It has never been calculated, but the men who knew the mathematics understood what it implied. And the answer changes what you think about everything that followed. From a single experimental tank in a dying war to a gun that finally answered the question American armor had been asking since Normandy. From the bureaucratic delays that cost thousands of lives to the 22nd engagement in Dessau that proved the mathematics could work in America's favor. From McNair's fatal conviction that heavy tanks were unnecessary to the Cold War doctrine built on the ruins of that conviction. That was the journey across 3 parts, and it ended as we left it with a question nobody had officially calculated. How many men died in the gap between what American industry could build and what American doctrine allowed? But before that question can be answered, there is another one. Simpler. More personal. What happened to the men who actually sat inside that machine? Staff Sergeant Joseph Madra returned to the United States after Germany's surrender in May 1945. He was not celebrated in the way that mythology might suggest. There was no ceremony specifically for the Super Pershing crew, no official recognition that the vehicle they had operated represented a significant milestone in American armor development. The war had ended. Men came home. The machinery of demobilization, processed millions of returning veterans with the same industrial efficiency that had produced the tanks they had driven, and individual stories disappeared into the aggregate. Madra went back to civilian life. He carried with him the specific memories that combat veterans carry, not the clean narrative versions that appear in histories, but the physical sensory memories of being inside a steel box, when a shell passed close enough to feel of waiting for a German tank to crest a pile of rubble of the particular quality of silence after an ammunition explosion. He did not speak extensively about his experiences in public. This was not unusual. The men who had done the most dangerous things in the war were frequently the least inclined to describe them. Corporal John Irwin was different. He wrote, "Not immediately, it took years before he processed his experiences into language, but eventually he produced an account of the Dessau engagement that became the primary source for every subsequent historian who examined the Super Pershing's combat record. His memoir was specific where it had direct knowledge and appropriately uncertain where it didn't. He described the German tank's turret leaving its hull and landing in the street. He did not claim with certainty that the vehicle was a king tiger. He said it looked like a tiger behaved like a tiger and died like nothing he had encountered before. This honesty is worth noting. The mythology of Dessau grew not because Irwin fabricated it, but because subsequent retellings simplified what he had reported with nuance. The ambiguity was edited out. The Panzer IV that historical analysis suggests is the most probable target became a king tiger because the story worked better that way. Irwin himself, when asked about it in later years, maintained that he could not be certain what he had destroyed. He knew what he had done. He was less certain what he had done it to. Captain Belton Cooper did not return to obscurity. He remained in the Army, continued working in armor and maintenance roles, and eventually wrote Death Traps, a memoir published in 1998 that documented the 3rd Armored Division's experience in Europe with a maintenance officer's meticulous attention to the cost of institutional failure. Cooper was not gentle with the decision-makers who had delayed the Pershing program. He named names. He documented the specific relationship between doctrinal resistance and American casualties. He was in his 80s when the book appeared, and he wrote with the clarity of a man who had spent decades deciding what needed to be said. Death Traps became an important document in the historiography of American armor in World War II, not because it was the only account of these failures, but because it was written by someone who had lived them at the level where the consequences were most immediate. Cooper had not read casualty reports. He had counted destroyed tanks. The engineers who developed the T26E4 gun received the specific recognition that engineering achievements receive in military organizations. Technical reports filed data incorporated into successor programs' capabilities, validated by post-war testing, and returned to the work of building what came next. Their names do not appear in most popular histories of the war. Their contribution exists in the penetration values of every American tank gun developed in the 2 decades following 1945, in the design philosophy that prioritized firepower in ways that McNair's doctrine had explicitly rejected. The T-15E2, which addressed the stowage problems of the T-15E1 through a 2-piece separated ammunition design, fed directly into the gun development programs that produced the weapons mounted on the M47 and M48 patent series. 25 production T26E4 tanks had been authorized in March 1945. The war ended before they were built. But the engineering work was complete, and it did not disappear. It became the foundation of what followed. The M26 Pershing's design lineage extended further than most people realize. The M46 patent, which corrected the original Pershing's underpowered drivetrain with the Continental AV1790 engine, served in Korea and proved decisively superior to the T-34/85 in tank versus tank combat. The M47 and M48 continued the development, mounting progressively improved 90mm guns and incorporating lessons from both World War II and Korean War experience. The M60, which entered service in 1960, mounted a 105mm gun, a direct descendant of the firepower philosophy that the Super Pershing's T-15E1 had embodied, and remained in frontline American service for 30 years, seeing action in Operation Desert Storm in 1991 against Iraqi armor. 46 years. From the Super Pershing's 3 weeks of combat in April 1945 to the M60's last major engagement in the Iraqi desert. A design philosophy traced across half a century of American armor development, all of it running back to the lesson that McNair had refused to learn, and that American tank crews had paid to teach. The M1 Abrams, named for General Creighton Abrams, who had commanded the 37th Tank Battalion in the famous Aracourt engagement of 1944, represents the fullest expression of that philosophy. Its 120mm smoothbore gun, its composite armor, its sophisticated fire control systems, all of these reflect the core insight that the Super Pershing had embodied in improvised form, that American armor needed to be capable of defeating the best enemy armor at combat ranges, not just adequate against average opposition. The M1 has been adopted or operated in modified form by the armies of Egypt, Saudi Arabia, Kuwait, Australia, Iraq, and Poland. The design philosophy it embodies: overwhelming firepower, adequate protection, reliable mobility, has influenced tank development programs in multiple nations. The lesson that McNair dismissed in 1943 became the governing principle of American armor for the following 8 decades. But the technical legacy, as significant as it is, understates what the Super Pershing story actually teaches. Because the most important lesson from the T26E4 program is not about guns or armor or penetration values. It is about the specific mechanism by which institutions resist correct answers. McNair was not ignorant. He was not incompetent in his domain. He was a capable officer who had built a coherent doctrine based on reasonable assumptions about how armored warfare would unfold. The problem was that he held his doctrine with the kind of conviction that made contradictory evidence feel like a challenge to his judgment rather than information he needed. When battlefield reports from Tunisia and Normandy demonstrated that his assumptions were wrong, his response was to question the reports rather than the assumptions. This pattern, the institutional conversion of inconvenient evidence into threats rather than information, is not unique to McNair or to American armor doctrine. It appears in every institution that has ever existed, military and civilian, in every era. The Wright brothers could not get the United States Army interested in their aircraft for 3 years after Kitty Hawk. The Navy's Bureau of Ordnance spent much of World War II defending defective torpedo designs against evidence from combat that they didn't work. The British Army entered World War I with cavalry doctrine that the machine gun had already made obsolete in the Franco-Prussian War of 1870. Radar, penicillin, the aircraft carrier, the ballistic missile. Each of these technologies was opposed by institutional actors who had built careers and doctrines around the capabilities they replaced. Each of them eventually prevailed, not because institutions changed their minds elegantly, but because the cost of being wrong became impossible to ignore. The Super Pershing's story follows this pattern exactly. McNair died in July 1944. The T26E4 was approved for production in November 1944. The timeline is not coincidental. The institutional obstacle was removed, and the decision that should have been made in 1942 was made 17 months into a campaign that had been demonstrating its necessity with every Sherman that burned on a French road. The men who paid the price for this delay were not abstractions. They had names. They had families. They had survived training and the Atlantic crossing and the beaches and the hedgerows, and they died inside vehicles that American ordnance knew were inadequate against the opposition they would face. The gap between what could have been built and what was built is not a policy failure in the abstract. It is a specific number of specific people. That number has never been formally calculated. The variables are too many, the counterfactuals too uncertain. But the engineers knew it existed. Cooper knew it. Irwin knew it. The men who drove Shermans through France and Belgium and Germany and survived knew it with the particular certainty of people who understood what had killed their friends and why. Now comes the detail that most accounts of the Super Pershing leave out. The detail that sits in the Army Ordnance Museum records and in the 3rd Armored Division's archived maintenance logs unremarked in most popular histories. The original T26E4. The single Super Pershing that fought at Dessau, that destroyed the German tank at the intersection, that watched a Panther crew exit their vehicle and surrender rather than face that gun, was returned to the United States after the war for technical evaluation. It was tested extensively. Its field modifications, the Panther armor welded to the hull, the improvised counterweights, the external stabilizer, springs on the turret were documented and measured. And then it was transferred to the Aberdeen Proving Ground in Maryland, where captured and experimental vehicles were studied. It sat at Aberdeen for years, then decades. The original Super Pershing. The only T26E4 to have seen combat anywhere in the world. The tank that Cooper's crews had armored with salvaged Panther plates and that Irwin had used to put a shell through a German tank's belly at an intersection in a ruined city was eventually scrapped. The specific date is recorded in Army disposition records from the late 1950s. The vehicle was determined to have no further evaluation value and was processed for scrap metal. The gun, the T-15E1. The weapon that had achieved what ordnance officials had spent years insisting was unnecessary, was removed before scrapping and is preserved. It exists. It can be examined. The barrel that Irwin fired in Dessau that achieved 1,500-yard kills and sent a German tank's turret into a cobblestone street is a physical object that can be measured and touched. The tank itself is gone, rendered down into steel that was almost certainly used to build something else. Appliances, automobiles, construction materials, the anonymous infrastructure of post-war American prosperity. The most capable American tank to have seen combat in World War II ended as raw material for the civilian economy it had helped to preserve. There is something appropriate about this, though it takes a moment to see it. The Super Pershing was never intended to be a monument. It was intended to solve a problem. It solved the problem it reached in time to address. And then it was consumed by the country it had served, its material recycled into a future it had helped make possible. From a maintenance compound in Germany, where a captain improvised armor from enemy wreckage, to a 20-second engagement in a rubble-choked city, to 50 years of American armor doctrine, to the M1 Abrams, still in service today, the line runs continuous. One vehicle, one gun, one crew of men who did their job with what they were given, knowing it should have been better, and making it work anyway. The Super Pershing arrived too late to change the outcome of World War II. That outcome had already been determined by industrial capacity, logistics, air supremacy, and the accumulated weight of Allied material superiority that no individual weapon system could alter. But it arrived in time to prove what American industry could build when institutional resistance was overcome, and that proof shaped American armor for the half-century that followed. McNair's doctrine killed men who didn't have to die. Cooper's improvisation saved the men in his vehicle. Irwin's gunnery destroyed whatever was at that intersection in Dessau. And the engineers who built the T-15E1 gun left a design philosophy embedded in every American tank that followed. The war was won by numbers and logistics and courage under impossible conditions. But it could have been won with fewer names on fewer letters sent to fewer families in fewer towns across a country that believed it was sending its sons into battle with the best weapons it could build. It wasn't. It knew it wasn't. And it waited too long to fix it. That is the cost of institutional certainty in the face of contradictory evidence. That is what the Super Pershing story is actually about. Not the 22nd engagement, not the flying turret, not the mythology of Dessau. The real story is the distance between what is possible and what institutions allow. And the men who cross that distance anyway, with whatever they have, because the alternative is unacceptable.